The plasma screen. It displays pictures from a video signal, much like any television. Except that to display those pictures, it relies on a fourth state of matter. A fourth? Normally, matter limits itself to solid, liquid, or gas. The plasma screen relies on yet another state of matter, called plasma. As a result of energy transfers within this very unique state of matter, this screen can display pictures. Okay, but how does it work? The plasma screen. The housing. The power supply. The multimedia interface. The electronics. The video card. And finally, the surface upon which pictures are displayed. The famous plasma module. It's made up of two thin plates of glass stuck to one another. It's here where, thanks to plasma, pictures are created. But to understand how, it's time to do some shattering. It all starts with an incoming video signal. For example, through a cable. The signal is sent to the video card, where it's decoded, and to the electronic circuits controlling the appearance of pictures in the plasma module. More than 2 billion electrical impulses are sent to the plasma module every second. The module's two glass plates are covered with transparent electrodes. And in order to transform these electrical impulses into pictures made of colored light, the plasma module needs plasma. The transformation happens between the electrodes, in the pixels. They're tiny cavities engraved on the rear glass plate and trapped under the front glass plate, laid out in a 1024 by 768 grid. There are precisely 786,432. Each pixel constitutes 1 point on the picture being displayed. Each pixel is divided into 3 subpixels. The bottoms of the subpixels are coated with phosphor, a substance that gives off light when excited by ultraviolet rays. When that happens, the first subpixel gives off red light, the second gives off green light, and the third, blue light. By combining these 3 colors, each pixel can produce 549 million different colors. The question now becomes, how are the ultraviolet rays required to light these subpixels produced? The answer is the plasma. Each subpixel is filled with a mixture of gas, xenon and neon. When an electrical impulse of about 300 volts rushes through a subpixel on its way to the electrodes, electrons from the gas mixture are violently torn off and suddenly float freely. That drastically changes the state of the mixture. It's no longer gas. It's now plasma. It's a highly energized state of matter. But it's a state that lasts only as long as the electrical discharge. As soon as the discharge ends, the freed electrons immediately return to their places, and the plasma once again becomes gas. What's important is that as they return to their places, the electrons release their surplus energy in the form of ultraviolet rays. It's these rays that excite the subpixel, which gives off light that combines with the light given off by the 2 other subpixels, and together, they light up the pixel. Every second, the plasma screen sends more than 2 billion electrical impulses into the subpixels in order to turn the gas there into plasma. The sole purpose being the ultraviolet emissions given off once the plasma returns to its gas state. All that so pictures can appear pixel by pixel on the screen. The plasma screen. To display pictures from a video signal, it colors each point on the screen, pixel by pixel, subpixel by subpixel, using a fourth state of matter, plasma. Impressive.